Good afternoon, students. Today is lesson 7 for our chemistry class. I hope you have studied the previous lessons very well because they are so important, as I told you before. Now, do you remember the previous lessons? We took oxidation and reduction. We said oxidation is what? A loss of electrons. And reduction is what? Gaining of electrons. Okay? What else did we take from last lecture? We took a reducing agent and an oxidizing agent, and I told you, I explained. We said a reducing agent, it's the substance, element, or compound that an oxidation process happened on it. In oxidizing agent, okay, it is an element or a compound that a reduction process happened on it. So please study the previous lesson very well. It is important. And also about the figures before, they are very important. Okay, so reducing agent, oxidizing agent, okay, reduction, oxidation, and we also took that it's not just about the electrons. We took that. We took oxidation is what? Gain of oxygen. And also we took reduction is what? Loss of oxygen. So you should go back to the previous lesson and study it very well. So today we will continue. Okay? We will continue in chapter 19 from page 616. Okay. Now the main idea in this chapter, the main idea in this slide, what is he speaking about? He's saying some substances can be oxidizers and reducers in the same reaction. But this is what for specific reactions. Focus, students, again. So this means some substance, okay, any element or compound in a redox reaction, both the same compound, okay, or element, okay, but in in most cases it is a compound, okay, and we will see examples today. The same, okay, substance, it is the oxidizer and the reducer. So we will see. Let's read together. So some substances can be both reduced and oxidized easily. For example, peroxide ions, okay, have a relatively unstable covalent bond between the two oxygen atoms. You see here, the electron dot formula is written as follows. So this is a very reactive, okay, they are or unstable, it is unstable covalent bond. So each oxygen atom has an oxidation number of -1. Do you remember before when we took the oxidation numbers? We said generally the oxidation number for oxygen, it is -2, except what? In peroxide it is -1. Also another case exception, if the oxygen was with the fluorine. Fluorine is a stronger electronegative atom. Actually, it is the strongest. So the oxidation number for the oxygen will be different. Okay, so in this case, the oxidation number is -1. The peroxide ion structure represents an intermediate oxidation state between O2 and O2 minus. Therefore, the peroxide ion is highly reactive. Okay, now hydrogen peroxide is a covalent compound. It decomposes into water and molecular oxygen as shown in this equation below. Okay, so now notice that in this reaction hydrogen peroxide is both oxidized and reduced. So you see here, this is both oxidized and reduced. How? Let's read together. Oxygen atoms that become part of gaseous oxygen molecules are oxidized. You see the oxygen atoms, you see they are oxidized. Okay, then what else? Okay, the oxidation number of these oxygen atoms increases from -1 to 0. So that's an oxidation process. Oxygen atoms that become part of water are reduced. You see, the oxygen atoms that become part of water are reduced. Look, from -1 to -2. Can you see here? So oxygen atoms that become part of water are reduced. The oxidation number of these oxygen atoms decreases. And as we took from the previous lesson, okay, if the oxidation number increases, this is what an oxidation process. And if the oxidation number decreases, this is a reduction process. Now, what do we call this process? What do we call it? It is called disproportionation. Okay, so it is, let's read it together, a process in which a substance acts as both an oxidizing agent and a reducing agent. A substance that undergoes this proportion is both self-oxidizing and self-reducing. So example, let's see example. You can see here. So disproportionation in nature. Disproportionation in nature. A bombardier, this one, beetle, you see, can repel large predators such as frogs with a chemical defense mechanism that uses disproportionation of hydrogen peroxide. Okay, so look here, the bombardier beetle defends itself by spraying its enemies with an unpleasant hot chemical mixture, as shown in figure 3.4. The catalyzed disproportionation of hydrogen peroxide produces hot oxygen gas. This gas gives the insect an ability to eject irritating chemicals, you see here, from its abdomen with explosive force. Okay, now one more example also. Now, again, so what is a disproportionation? Generally, you see, in redox chemical reactions, one entity or substance, element or compound is oxidized and other is reduced. And this is in a redox reaction. In this proportionation reaction, one entity undergoes both oxidation as well as reduction, and two different products are formed. You see here, two different products are formed. So like before, you see here, so same, it undergoes reduction and oxidation, and you see two products are formed. So let's continue. Another example, you see, a great example is chlorine mixing with water. Now, elemental chlorine, Cl2, has a redox number of 0. Why? Because it's a pure element. We took it before. The oxidation number of a pure element, it does not matter the number of atoms. It is 0. Became HCl. So now the oxidation number for Cl alone is -1. And HClO, it has a redox number of +1. So do you see now? The chlorine, it went from this atom, from here to here. Now what? From 0 to -1. From 0 to -1. So the oxidation number has decreased. Okay, so it is what? Reduction. And here from 0 to +1. So the oxidation number what? Has increased. So this is what? Oxidation. Therefore, chlorine has been both oxidized and reduced in the same reaction. This is called disproportionation. Okay, so now we have reached the end of section 3. So this is the formative assessment, and as I tell you always, okay, so now it is very important, read and study these questions very carefully. Okay, so for example here, describe the oxidation and reduction strengths of alkali metals and halogens. Okay, now here, would Cl2 be reduced by I? Explain. Okay, remember the above, which element is above each other in the periodic table. Okay, so remember, in each pair here, which is stronger oxidizing agent. So remember what is meant by disproportionation. This is our lesson today. So please study these questions very well. Okay, I hope you have understood. Okay, this is the end of our lesson.